Welcome to Recovering an Interpretation from a Truth Tree, Part 2. We want to look at a couple of more examples of how to recover an interpretation from a truth tree in predicate logic. So let me start with this one this time. It begins with there is an x and there is a y. So there is a pair xy such that sx and cy and wxy. And that's our first set member. And then the second one is there is an x and there is a y. So there's a pair xy such that sx and cy and not wxy. Now, I've picked these two sentences because they are examples that we've seen before, very similar to examples that we've seen before. The first one might symbolize, for instance, some student owns a cell phone. And the second one symbolizes some student does not own some cell phone. And now what we want to show is that, of course, these two sentences can both be simultaneously true. And the way to do that is to complete the truth tree. We should get a completed open branch, and then we'll be able to recover an interpretation from that completed open branch. So let's proceed. Here, both of the sentences, lines 1 and 2, have existential quantifiers as their main logical operator, so we have no choice but to start dealing with that. Let's start with number 1 first. So we're going to instantiate the first quantifier, the x quantifier, to the letter a. So we're going to write down SA. We're going to put an a in every time we see an x. And we have to get a little bit careful here. We have to proceed a little bit carefully so that we don't make any mistakes. And that comes from 1 by existential decomposition. And then we can instantiate this existential quantifier on line 3 again, and the way to do that is, of course, to use a constant that's foreign to the branch wherever we see y. So we'll write down SA and bracket CB and WAB, and that comes from 3 by existential decomposition. And now we do basically the same thing with line 2. So we first instantiate the x quantifier, and now we have to pick still another constant that's foreign to the branch. So for example, we're going to now use c, so s little c and cy and not w little cy. Again, just going a little bit carefully here so we don't make any mistakes, and that comes from 2 by existential quantifier decomposition. Of course, every time we use an existential quantifier decomposition, we check off the line, so I should have checked all of those off already. We have one more instantiation to take care of here on line 6, and that is to get rid of this existential quantifier by doing this sc ampersand, and every time we see y, we need a new constant, so we're going to use d, cd ampersand not WCD. And that comes from 5 by existential quantifier decomposition. Now, when we look at our tree, we see lines 4 and line 6 are the only ones that are not decomposed, and both of those are just conjunctions, so we can just stack here SA and CB and WAB, and that comes from line 4, of course, by conjunction decomposition. And we can stack again, so we can write down CB and WAB. And likewise, we can do the same thing with line 6, so we can write down SC and then CD ampersand not WCD, and these last two lines, 11 and 12, come from 6 by conjunction decomposition. Lines 9 and 10, by the way, came of course from 8 by conjunction decomposition. And then finally, lines 13 and 14 are going to be CD and not WCD. And those are going to come from 12 by conjunction decomposition. So when we look at our tree now, we see that it has a completed open branch. And so we should be able to recover an interpretation on which the original two sentences are true. Now let's just identify a few things here as we look at this completed open branch. First, let's look at the constants that appear here: A, B, C, and D. So we're going to need a universe of discourse with at least 4 things in this interpretation. And in a way, that should sort of seem correct, especially if you think of the interpretation about, some student owns a cell phone, and there's a student and a cell phone such that that student doesn't own that cell phone. It sort of seems reasonable to expect that we're going to need a universe of discourse with 4 things. And if it doesn't come too quickly, that's okay. It'll come after we look at what the interpretation actually is. And the way to recover the interpretation is as follows. Now, so that I can keep it all on the same page, I'm just going to cover this part up over here, because all the sentences in 1 through 5, in fact, actually also 6, those are all checked off. So for now, I can just pretend they're not there. I don't need them for anything. And I can recover the interpretation just from this fragment of the tree. And the way I do that is, first, I identify how many different constants I have. And that tells me how many things I need in my universe of discourse. As before, it is convenient to use numbers in our universe of discourse. So I'm going to write 1, 2, 3, 4. And those are going to be, of course, A, B, C, D. And then I'm going to need our predicates. So I'm going to need SX. I'm going to need CX. I'm going to need WXY. And then I'm going to need A, B, C, and D. And, A, B, C, D is going to be 1, 2, 3, 4. And now my predicates are going to have as their extensions sets. And remember, we adopted the convention of not worrying about writing 1 tuples with angled brackets. So now as I look up this branch here, I see that A is an S, and so is C. A is 1 and C is 3. So 1 is in the extension of S, and 3 is in the extension of S. And that's it for S. For C, B is in the extension of C and D. So now B is 2 and D is 4. So that's the extension of CX. And for WXY, I have only one piece of information here, which is that A and B, in that order, are in the extension of WXY. So that means that the extension of XY is the ordered pair 1, 2, because A is 1 and B is 2. And this interpretation is an interpretation in which the set members are both actually true. Now let's just verify that. Let's see if we can make sense of that, to put it that way. And so what I'm going to do here is just take our interpretation and display it right beneath our sentences so that we can see whether or not we've done a good job here with what we need to do. So we want to test to see whether this first sentence is true on this interpretation. So this sentence, again, number 1, says there's a pair XY such that the X is an S, the Y is a C, and the pair XY is in the extension of W. And our question is is that really true? Is there really a pair that satisfies all of those conditions? And the answer is that, of course, there is, because the pair 1, 2, right here, satisfies all those conditions, right? It satisfies those conditions because 1, which is the x, it's the first member of the pair, 1 is certainly in the extension of S. 2, which is the y, the second member, is certainly in the extension of C, and the pair 1, 2 is in the extension of W. So that makes that sentence true. Now let's look at the next sentence. This one says there is an x and there is a y such that Sx and Cy and not Wxy. Is there a pair of numbers such that the first one is an S, the second one is a Y, and they are not, that ordered pair of xy is not in the extension of W? And the answer is yes. The pair 3, 4. 3 is an S, 4 is a C, but the ordered pair 3, 4 is not in the extension of Wxy. And so what you can do as a little homework assignment is try to convince yourself that this all makes sense in terms of thinking of students and cell phones by, instead of using the numbers 1, 2, 3, and 4, put in for 1 and 3 names of students that are going to be your A and your C, maybe Alice and Carlos. And then for 2 and 4, put in individual names of cell phones.